To make the screen you are holding, someone had to blow up a mountain. Because the sand on your local beach? It is garbage for this. Most people assume glass is just melted sand. Heat it, cool it, done. That assumption is missing everything that actually matters. Every single day, more than 100,000 tons of glass are produced around the world. Every window, every bottle, every screen you have ever touched came through the same chain. And that chain starts not on a beach, but hundreds of meters underground. With a truckload of explosives, glass requires silica sand with a purity of 99%. 1% of iron? Your glass turns green. Too much clay? It goes cloudy. That level of purity does not exist on any beach on Earth. It exists in hard rock veins buried deep underground, and the only way to release it is with industrial explosives. Teams drill 11 meters into solid rock, pack ammonium nitrate charges, and detonate the entire face. Excavators scoop the rubble into trucks. Industrial mills grind it into fine uniform grains. Then it enters washing tanks, processing up to 220 tons per hour, where high-pressure water jets and magnetic filters strip out every last trace of iron and clay. After 15 minutes of continuous agitation, the sand is clean, but clean sand alone still cannot become glass at any practical temperature. Pure silica melts at 1,700 degrees Celsius. Getting there costs a fortune in energy. So glass makers use a 3-ingredient formula that has not changed in over 2,000 years. Silica sand forms roughly 74% of the mix. Sodium carbonate acts like a molecular crowbar, forcing the silica molecules apart at a far lower temperature. Limestone goes in last as the stabilizer because without it, the soda makes the glass slowly dissolve in water. 3 ingredients, 1 purpose. But here is the ingredient nobody puts on the label: old glass. Recycled glass, called cullet, gets loaded back into every new batch. 1 ton of cullet saves 590 kilograms of raw sand and cuts melting energy by up to 20%. The secret ingredient in new glass is already glass. The blended batch enters a gas-fired furnace. The temperature climbs to 1,650 degrees Celsius. For reference, molten lava runs between 700 and 1,200 degrees. This furnace runs hotter. Workers wear fireproof suits and Kevlar gloves just to be in the same building. The mixture stays molten for a full 24 hours, not because it needs more heat, because of the bubbles. As the materials fuse, gas pockets form throughout the liquid. A single trapped bubble makes the glass hazy, a bubble in a load-bearing panel, and the structural strength is compromised entirely. Fining agents, sodium sulfate, act as a chemical surfactant, coaxing every gas pocket to the surface and out. What flows out after 24 hours is not sand, soda, or limestone anymore. It is liquid glass, glowing orange, dense as syrup. Perfect. Now here is what most people expect: molds, rollers, pressure. But every window panel, every flat glass surface you have ever looked through was made by doing something that sounds like a catastrophic mistake. You pour liquid glass onto liquid metal, specifically molten tin. Tin is denser than glass, 6,500 kilograms per cubic meter versus 2,400. So the glass floats on the surface, spreads under gravity, and levels itself into a perfectly flat ribbon. No roller, no press, no mold can match the surface this creates. What engineers call a fire finish, optically smooth on both sides, created entirely by physics. But the tin bath runs into a problem. Tin oxidizes. Expose it to open air at those temperatures, and it contaminates every sheet it touches. So the entire float bath runs inside a sealed chamber filled with hydrogen and nitrogen, a controlled private atmosphere protecting a river of liquid metal so the glass floating on top stays completely pure. Every window you have ever looked through was born inside a bubble of invisible gas. The ribbon leaves the float bath at 600 degrees. Now it has to cool. And this is where most glass in history was ruined. Cool it too fast and the outer surface contracts before the inside can follow. The stress builds, and the glass does not crack. It explodes, not into shards, into a crystalline spray. This is why every sheet passes through a layer, a long controlled tunnel where the temperature drops in precise stages. The layer removes the internal stress before anyone touches the glass. High-speed cameras scan every panel. Diamond blades cut each sheet. Robotic arms stack them with protective layers between each one. Before we finish, remember the man doing the dishes? In 1959, an engineer was helping wash up after dinner when he noticed how a piece of soapy fat floated on the washing water. Perfectly flat, perfectly level, all on its own. He spent the next 7 years turning that single observation into the float glass process. Every flat pane of glass on Earth today, every window, every phone screen, every car windshield, traces back to a greasy kitchen sink and someone paying attention. He was knighted for it. The next time you press your hand against a cold window, you are touching a mountain. One that was blasted apart, purified for 15 minutes per tone, fused hotter than lava for 24 hours, floated across liquid metal inside a sealed atmosphere, and cooled with a precision that took decades to perfect. Not fragile, not simple. The most precisely engineered ordinary object you will ever touch. If that changed how you see something you walk past every day, share it with someone who has looked through a window their whole life and never once wondered what it actually is. More hidden truths behind the things you never question, right here.